A little bit more here. Keyboard. Hello. Hey, how are you? So welcome to the Coffee Lab, and I'm Chris from AltoFab Lab, or Chris from the Coffee Lab, and today we are going to talk about CNC milling, 2D CNC milling with Fusion 360 and Recontech 1312 machine. We are going to use a ready design, and I just want to. So here we are in Fusion 360. And so I designed a simple chair structure. So this is what we are going to make today. So there are some snap fit parts, so we could actually go through the whole design history here to check what's going on. So if we see the sketch, so I started with a circle, then I extruded a circle and continued with another sketch, which is just one part of the leg. Then I extruded it in a symmetric way, and yeah, then I used a circular pattern in order to duplicate those, and then I merged those together in pairs. Here, yeah, I created a cutout, so in order to be able to connect these together, and then I extruded the cutout in a negative way. Then I used one of these legs in order to subtract the other one from it, and yeah, some other snap fits, extrude a snap fit, again repeat a pattern, combine everything together, and then subtract these so these legs from the top part, so that we end up with having pockets. So if you now look at the bodies here, so the top one is this here, so it has a holes or pockets, and then these two parts kind of snap in, like fit into it. So this one has a pocket on the bottom, and this one has a pocket on the top. So yeah, what do we do from here? So once you have this sort of design, so when you want to mill it, you do the following steps. So you should take care of the material and other things. So in order to make things easier for you in the following slides or the following minutes, I'm gonna rename this to top and leg A, leg B. Another thing that I'm going to do is I'm going to convert these into components, so that each of them, they have their own coordinate space inside, and we can move them around, so which is going to be necessary when we are going to lay out them on material sheets. So the next thing is actually to get some information about our materials, and I have some sheets over here. This is the material. So, and we have several sheets of this. So this is a black 1 centimeter thick MDF. I measured its thickness. It's actually 10.2 millimeters. So let's see. I'm gonna take this measurement tape and gonna measure it along the x-axis. So it's just 38 by 113. And I'm going to enter it in the parameters. So in the parameters, I set 4 parameters that are defining the stock. So we probably are going to use 2 pieces of stock, but let's see. And so for the stock 1, we can enter 380, and this was 16, like so. And by taking this into account, I can create a new sketch in order to sketch those out. So, and in the sketch mode, I'm going to create a rectangle, and I'm going to give the dimensions depending on the parameters. So stock size, stock 1 size X, stock 1 size Y, and I'm going to make sure that it's positioned somehow. Okay, now it snapped. No, it didn't position somehow accordingly in respect to the origin of the workspace. So I'm gonna make it horizontal, vertical here, and then add a dimension between the center point and this one. And now it all turned black, so which means that it's completely nicely constrained. And I'm going to show it. Hide the other sketches. And so if I go to modify and change parameters, you'll notice that I also have a parameter for the material thickness, which is 10.2. And I'm going to use that to extrude this. Like so. And then I'm going to rename it to stock 1 and convert into a component. And now I'm going to use the assemble functionality of Fusion 360, which is a part of the design workspace. And I'm going to make a joint between this object, like the top part of the chair, and the plane. And I'm going to select planar as the type, and I'm going to flip it around so it kind of snaps into the material, and hit OK. Now, if I ground the material and try to grab and move the part around, it's going to move, and it's going to always stay planar towards the material. And let's do it with the rest of those. So the two other parts. So joint. Yes, I want to capture position. So we are kind of matching faces to faces here. And then when we flip it around, then it's kind of melting into the material. And then here, yeah, so we can move this around to align it. And I have the feeling that it's probably not going to fit to the other part if we are going to try to assemble and make a joint, capture position, this, that, and then rotate it 90 degrees. So there's a bit lack of space, so that means that we should actually use another one more piece of material, which would be probably approximately the same size. So so this is why I have the stock 2 size X and Y, and I have a piece that is exactly the size, I think. This is that stuff. No, like measurement tape. I just thought that that's the measurement tape. So this is also 38. Yeah, approximately the same. I could take also the smaller piece. So I could actually use the same measurements, but 380 and 116. Okay. And I'm going to go to sketches and open the last one. And make another square. Or yeah, square. No, rectangle. Rectangle. So this is rectangle. And add a dimension over here. So stock 2 size X and stock 2 size Y, like so. And then I'm going to make these 2 points horizontal, vertical, and add a distance between this and that. And 500 is fine, yes. Finish sketch. And I could move back to this extrude option here and select this other surface for extrusion as well. Now there's stock 2, which we can create, convert into a component as well. And now if I click here, there should be a way of changing the I want to delete the joint, and I'm gonna create a new one between this and the new one, and also flip it around so it melts into the material, and also ground the stock 2. So we cannot move it around, but we can move only the objects, like so. So it's important to leave a reasonable spacing between the parts. Because we are going to use rotary tool in order to cut these out. And I've chosen 2 tools for the presentation. So for the preview, which are like 2 6mm tools. So one is a normal upcut tool, and the other one is a downcut. So I actually made one chair just before with the upcut, and so for this demonstration I will mainly use the downcut. Yeah. And then it's up to you to choose whichever you want to use, and you can use also the way described by Neil yesterday, that you use the downcut for the upper part, so for the upper layers of the cuts, and then you use the upcut for the rest of the cut. So that's that. And yeah, in order to we need to kind of make sure that the parts are not too close, so that the tools actually fit in between them. But this is fine, so not too dense. One more thing before we move to the manufacture space here, where we are going to do the tool paths. We need to take care of these so-called dog bones, or like these circular extensions, extension pockets. So because if the tool is round, it's going to leave a fillet here, like a round fillet, and we want to avoid that, because if it's the case, then the parts are not going to fit well together. So we need to create something like a circular feature here that is going to accommodate the other part nicely. And in order to do that, I have installed this dog bone plugin. So if you don't have it in Fusion, then you can go to Tools and use the Add-ons panel, and go to Add-ins, and thank you. And here, when you click on plus, you'll be able to select the plugin. But the plugin itself, so if you see that there's the default Fusion 360 plugin, do not use it. Because you should look up this site. So you should look up its GitHub repository. And yeah, if you install it now and then it works, and then in a year it doesn't work, then probably there is an update here on the Git repository, and all you should do is just download it and install it from scratch. Yeah, and then you can go to the GitHub repository and then download it as a zip file, save it to a place where you know you can find it, and then use the Fusion 360 scripts and add-ins panel in order to add it. When you added it, then you have to select it, hit run, and then also optionally check the run on startup. So yeah, and in order to create the dog bone, so I go back here to solid tool panel, and I click on the dog bone. So it's asking me to select a face, and I can select one of the faces of the objects, and it's going to automatically select the edges, which have to be dog boned, so to say. And for the tool diameter, yeah, I said that it's going to be the 6mm tool. And for the offset, I entered 0.1 because so if you also define later the tool diameter as 6mm for the toolpath generator, so it sometimes might complain and might not cut completely through. So this is just to give the toolpath generator a little bit more space to get into the narrow areas. It could be even less than that, I guess, but yeah, 0.1, it's not going to make any difference. Then I usually use the static ones, the static dog bones. You could use also parametric, so which would allow you to change those later, but static are fine for now because it's not going to slow down my Fusion. And yeah, here you can select type. Yeah, let's select a normal dog bone. And what is settings here? Yeah, more like debugging related stuff. And then hit OK. And it's going to automatically create dog bones from all the pockets that you have there. So also here. So there's a way how you can create that in sketch level, so I can show you quickly. So for example, you have a square and you want to create this, yeah, like let's say like this, and then this is going to be like a frame that is going to be cut out, and you want to accommodate this pocket here. So the way you do it is you create a circle. So the circle has a nice center over here. Then you create a construction line from this corner over here, and you convert it into construction line as well. And then you define an angle between this and this. You set it to 45 degrees. And then you define the length of this, which should match the diameter of your tool together with the offset. So I'll set it to 6.1, like so. And maybe put this here. And then I'm going to coincident this point with that point. And lastly, I also need to set the diameter for the circle, which is going to be 6.1. No, 2 times it, 12.2. Like so. And then when you are creating an object out of this, then you just extrude this part over here. So it's not going to select these two segments. So this is an if you don't want to use the dog bone tool. So when I started using Fusion, I did not want to install any plugins, and thus I made all my objects so in this way. But then at some point it just becomes very labor intensive, and you just want to get your thing done as fast as possible. So you decide what is better for you. So maybe to better understand how dog bones are calculated, you can do this, and then after you can switch to the plugin. So it's really up to you. Also take into account, so when you're making your sketches, that you have some sort of a parameter that that lets you easily control a similar feature as the curve in laser cutting. But so in CNC milling, so yesterday in lecture there was also this part about the run out, so that sometimes the tools are not so precise, so they wiggle, and thus they are eating more material than they are supposed to eat. And this is where you have to kind of make the pockets a bit smaller in your design, so that the parts fit nicely together. So you will need to test that also. So in our case, we don't need this anymore. Okay, so let's continue with the dog bones. So here, let's create dog bones for this object here. The parameters here are all the same. Didn't like something. Also, to make it easier for you to select those, you can make them selectable and unselectable, like so. Yep, here we go. Here we go. So yeah, now we are ready to move on to manufacture workspace over here. And the milling process starts with creating a setup. And for the setup, we need to specify the stock. And I would say that there should be one setup for a piece of stock. And I'm going to take it from a solid. So since we have these materials here already, I can go to models here and select the stock one. So, and then another thing is that we need to select a point which is going to represent the 0 point for the machine. So when you're milling the PCBs, then you remember you need to set the 0 point. So it works in a similar way also on the bigger CNC machine. So this is how you set it virtually. And then you will need to make sure that the same point is used also on the machine. Okay. Yeah, we need to select the models, and it's going to be these are going to be the legs. Okay, and basically what we need is just one cutting strategy, or a cutting path, or cutting procedure. And yeah, up here you can see that there are all kinds of milling methods that you can use, milling strategies. And so for 2D, you see there's pocket, face, contour, slot trace, but most of the time I think you are going to use the 2D contour for cutting, and then sometimes you're gonna need a pocket, And then in order to level your material, you probably are going to use the face. So we don't really have anything for this, I think. I never done it really. Engraving could be a good thing to try out. But yeah, so this time we need a 2D contour. And then in one of the following weeks, there's going to be molding and casting. And we'll need to use 3D milling in order to produce a positive wax mold for our silicon molds. Then we are going to use some of the 3D milling strategies. But for this time, I'm just going to stick to 2D contour. And once you click on that, a panel is going to open. Here in this panel, you can specify all the needed things, all the variables that you are going to give, like, or that you are going to change in the machine or set into the machine. So first of that is the tool. And just for a better understanding, I'm going to add a tool from scratch. So there's a tool editor built in Fusion. So you click on the new tool icon and let's give it a name. So we are going to use this downcut tool. So it's going to be 6mm, 2 flute, flat downcut. And the next thing that is important is the cutter. So it's going to be a flat end mill, and it's going to have 2 flutes. And the material is going to be high-speed steel, and the diameter is going to be 6, and the shaft diameter is also going to be 6. And here we need some measurements. So, and for this tool, the overall length is 80mm, and then the body length is how much of this is going to be visible outside of the collet. So usually you put it in approximately 2 centimeters deep, so that means you're gonna have 60mm that we can use for cutting. So 60mm of free space. So we could potentially mill a material that is 60mm thick. Then the flute length, in this case, it is 20. And then we don't have any shoulder, so that doesn't matter really, but it should be bigger than the flute length. And then another important point is feeds and speeds. And here an important value is the feed per tooth. And for a 6mm tool that is cutting MDF, it is 0.3mm. So this is amount of material. So next to the CNC machine, actually, we have a nice table. So this one here, so I'll also show it in the screen. This one, so here, you can see it also on the projector there. Yeah, so here you can see the thickness on the top on the top part. You can see the thickness of that diameter of the tool, and then different kind of materials and how and what are their recommended chip loads or feeds per tooth. So to better explain feed per tooth, it's so the tool is turning, right? And then each time it turns around and it moves forward, it removes a little bit of material in the direction where it moves. So, and if you linearly measure the amount of material that is being chipped off, so that's the chip load. so that it's kind of how much the tool moves forward. So, and that's also the amount of the material that is being chipped off. And knowing that, then the number of flutes of the tool, so flutes are the cutters, so if there are 2 cutters, that means that it's going to chip 2 times per revolution. And the spindle speed, we can actually calculate the cutting feed rate. So the spindle speed is going to be 16,000, so the machine can go up to 21,000, was it? And Fusion is going to calculate the cutting feed rate for us automatically, but it is basically the number of flutes that we have times the chip load, so which is 0.3, times the spindle speed, which is 16,000. So and we end up with the same value here. So this is important. So this is a really basic, simple formula, but it is very important for you to be able to calculate feed rates yourself for any material. So for plastics, for aluminium. So I really would like to be able to cut aluminium here, but not now, maybe later. Yeah, but all kinds of wood and plastics you can cut here. So for different types of those, just try to find the correct chip load, depending on the tool and so on, and use this formula. And then here, so ramp feed rate and plunge feed rate. So plunging is when the tool goes down. So this is, so here I usually take 1/2 of the, of the chip load of the horizontal movement. And that's it. And then you can hit OK. And OK one more time. And here we go. So this is now a tool that is selected. And the next step is to select geometry that we want to cut. And you should always select the bottommost line that you want the tool to cut around. And another thing is to check whether this little arrow is outside the actual object that you want to cut, because if it's inside, it's going to try to mill a pocket. So it's going to assume that this is a negative part, so that you kind of want to cut a window. But in our case, we want to cut around, we want to cut the part out, so that we want the tool to move around. So make sure that the arrow is outside. So here it's really hard to tell, but if we click on it, we see that it's inside, so the other option is just that it's outside, like so. Another thing that we want is tabs. So here was a nice visual description on what it is. So in Fusion, it's nice then whenever you hover a feature, so they have like nice visual explanation of what all these terms actually mean, because there are a lot of new terms. They take some time to understand. So tabs are these little tabs that actually hold your material in place when it's being cut out. So if there would not be any tabs, then there's potential of the actual part moving, flying out, damaging the tool, and if there's not enough safety, then you yourself or objects around as well. So we want tabs. So in this case, I'm going to set them to 8 millimeters times, so 2 millimeters thick. And I'm gonna use distance for positioning them and enter 200 millimeters as the distance between those. And here I have to hide the stock in order to properly see how they are going to look like. So these are the tabs here. And then we need to go to the passes tab over here. And we don't need to touch anything here, but we need to enable multiple depths, and we need to set the step down, sorry. So this is how deep the tool will go per pass. And yesterday there was the discussion also that it should be not more than the diameter of the tool. So in our case, it's a 6mm tool. I'm gonna go 3mm deep, like 1/2 of the tool. That's fine. And then for the stock to leave, so usually you use this for 3D milling, so that you want to leave a little bit of material. But in our case, we are going to use negative stock to leave, which means that we are going to cut more than necessary. And so radial means that we want to operate on the XY axis. So on the XY axis, we don't want anything extra or to cut more. But on axial stock, so axial is the one that goes up and down. So we want it to be negative, and I want it to be 0.5, so 1/2 millimeter. And then I can hit OK. And these blue lines over here, so these are the tool paths. And to better understand what these are, we can simulate. And simulation is important also because you can spot some errors in the process. And so here is a panel that you can use for playing it back. So here on the simulate panel, you can enable or disable the stock visibility or the toolpath visibility. In the info and statistics, you can see all kinds of information and statistics about it. So here it shows that it's going to mill for 2 minutes. So yeah, you can compare if it's precise or not. And here with this, you can speed it up. You can see whether it actually does what you want it to do. And it seems all right. So when your toolpaths are ready, you want to export them. And in order to do that, you go to the post-process option over here. And so for the Recontech 1312, we are using Mach 3 mill post processor, so which you can find under generic posts. And for the units, of course, we're going to use millimeters. And we hit OK. And we save it somewhere. Just save it here. Okay, and then we can also generate toolpaths for this other one, and for that we could make another setup. So new setup from solid, this solid. Not all of it, I just need the other stock for the model. I want this one. Okay. And basically what I could do, yeah, I want to move this out. I could just copy this strategy. So copy, paste. for the geometry, I just want to select this. Those. And yeah, again, like just make sure that the arrows are inside and this arrow is outside, because these are the pockets that we want to cut, and then this is the contour. The tabs, and hide the stock in order to see them better. So here they are. And everything else is as in the previous toolpath generation process. Hit OK. These are the paths. And let's export this so we can simulate it first. Like so. And let's export that as well. So share top 6mm down cut. Okay, so and yeah, let's take a 5 to 10 minute break, and I'm gonna move the setup to the CNC machine, and we continue there. So this is the Recontech 1312, the milling machine of the Auto Fab Lab. So it's a simple 3-axis machine. So this is the spindle over here. You can install the tool over there. It has a chip extractor, so you after mounting the tool, you hook up the chip extractor, and it helps you to remove the dust and the chips, so it doesn't end up on the ground, so you don't have to clean up so much. Then it also features a vacuum bed, so which is capable of pulling the material downwards. So even though it has a rubbery bed where you can place your material, so when you're cutting things, when you're cutting through the material, you don't want to cut into that. So this is why we use it as Sacrificial Layer. So which in this case it's MDF, and MDF is good because it's porous and it lets air through. So so the vacuum or the air is being pulled through the material, and then it's pulling the material down, and it stays in place. In order to turn on the machine, so this one, yeah, this is how it looks like. So there's a little computer on top of it, then there are some buttons, so the emergency stop on the left on the left side, and then a green power on button, power off. And then on the right side, there's the vacuum pump on and off button, so it's kind of a toggle. And then here, so this is the switch that you need to use first in order to turn it on, like so. Then, when that is done, you move on to the buttons that are higher, and you press the green power on button, and then you wait for 15 seconds around, because so this big box it has kind of a computer inside, and the computer wants to establish a network connection with the computer on top of it, so with this laptop, and in order to do so it needs a little bit of time, so they need to kind of intercommunicate the IP addresses and so on. So when that is done, and you should open this Mac 3 software, and you should be in the administrator mode in order to do that. If you're not, so yeah, then you should click run as administrator and ask someone from the lab to enter the password. You hit OK. And this is a Mac 3, so the control software that we use here in order to drive the machine. So on the left side here, you will see the G code when you load it. So here you can see the coordinates of the tool that is moving around. So X, Y, and Z. And then on the right side here, usually when you load the toolpath, then you can see a little preview of that. And here are all kinds of, so this is the most important part probably. So there are all the functions that you will need. Then, so the feed rate section is sometimes very useful. So when you're not sure whether you set the feed rates right, then in a similar fashion as you do with SRM20, so you can slow it down by a certain amount of percent. Yeah, and then there are three things that you should do before you start doing anything else with a machine. One is, so there are three main things. So one is you have to hit this blinking reset button. Then you need to check whether the soft limits are on, so because they might be gray, and then you just click on them and then they become green. And then you hit referential home, which is going to move the machine to its machine 0 positions. And this is where the soft limits are important, because it doesn't have any hardware switches, so you need to kind of specify that it internally has to kind of software-wise detect where it is at the moment. So otherwise it can happen that it just falls off the table, and it's bad for the machine, and if you're close, it's bad for you as well. And then you can use arrow buttons in order to move it around. And if you hit and hold shift and then use these arrow buttons, then you go into the jog mode, so it moves faster. And in order to move the tool down and up, you use page down and page up. And the same thing applies here. When you hold down shift and press the button, then it moves faster. So for now, I'm just going to move it away a little bit. I'm going to make sure that we set up the material properly. And as you see, when I remove the sacrificial layer, so these vents are being uncovered, and we want them to be open in places where the material covers them. So we have this piece of MDF. So we see that it's kind of too small to cover all four, but it's good enough to cover these two on the left side. So what I'm going to do, I'm going to close down these two. And I'm going to arrange these rubber bands that you see here in a way that they fit nicely under the material. So usually I just put it closer like this in order to see better how to align those. So, like this. And another thing that we need to do, so before we put the material, I mentioned about the sacrificial layer. So before we put the material, you put the sacrificial layer on, and I usually try to align it with the corner of the rubber bands so that I approximately remember where the rubber bands were. I'll use a bit of compressed air to remove dust. Usually when there's more dust, you should use the masks, so the air-fed respirators. So we have 2 of those. Especially when milling MDF, and if you are more than 1 hour in the CNC machining room and you have to mill and then clean up and repeat, and please use those. So they have filters here. There's a pump that is pulling the air in, and then it's blowing basically clean and fresh air onto your face that is inside here. And the benefit of this is that no dust comes in. So all the air that comes into the mask gets filtered through these filters, and then the air goes into the mask, and if the air flows outside, passing by this foamy stuff. So if you're having a mask where you have to pull the air in yourself, then there's a risk that the air gets in from the sides. So whenever possible, use these sort of masks to filter out, fine dust. Or so this is, I don't think that this is going to protect you from coronavirus. This is not good enough. And then, so here on the back side there's a battery. So you connect it to the pump with this wire, and then you press this button here in order to activate it. And then it's ready to put it on your face. Okay, for now I'm just gonna switch it off. So you can take a closer look. Now, so we set up the sacrificial layer, so there are the rubber bands set up underneath. I'm gonna put the material on. Like so. So I think I lined it well. Next thing is to use this button in order to activate the vacuum pump. But before you do that, there's another safety recommendation, which is these headphones, which should be on. So anybody who is in the room should be wearing this. So whenever the vacuum pump is being used. So like these ones, these go together with a button. Goes like this. You put them on, and then you push the button. And then you'll realize that you cannot really move this, and that's good. So since these are 2 MDF pieces, so the thinner one and the thicker one, so they both let air through, and they are not generating enough pressure, which kind of is important. So you can check this meter down here in order to see whether the pressure is enough, is pulling enough. So in this case, it's gonna. So it should be on the green level. So the pressure is good when it's on the green level, but it's not going to happen with this material because it's too porous. So the air is just flowing through. So with other materials, so if you are milling like a bit bigger pieces of wood or something that has to be held down really nicely and properly, you should aim for the green area. But in this case, it's going to look like this. Whether it's possible to see on the camera, but you get the idea. Here in this metal closet, I'm not going to show it on the video, you can find the collets, and for each shaft size there's a different one. So in this case we are going to use a 6mm one because we have a 6mm shaft, so this. And usually when setting up the tool, it's a good idea to use this spongy thing, this foam, and these two keys. And you start with removing this nut here, and you insert the collet in here, like so, and it should snap. You should always make sure that it ends up being flat with the bottom of the nut. And then you attach it here to some extent, and that extent should be just enough, so it should be strong enough to, and loose enough. It should be loose enough so you can insert the tool. So, and then make sure that you're inserting it at least like 1.5, 2 millimeters, 2 centimeters deep. So it's being supported properly. And then with your hands you can tighten it a bit, and then use the keys to finalize the tightening. And in this you have to think about you squeezing the lemon, and as if you would be wanting to get the last juice out of it. So this is just enough. So we are done with setting up the tool. Now is the Z calibration. And as you remember in Fusion, we actually set the origin to the bottom of the material. So this left closest corner. In order to set the Z properly, we need to move the material a little bit, and we are going to use this sensor. And we'll need to activate the vacuum, because the Z is going to change when the vacuum is going to be operating. So when the vacuum is on, it's pulling the material down, and we are going to lose a millimeter or a fraction of a millimeter. So before we activate the vacuum pump, let's just move it closer. So my recommendation is also to try to position the tool as close as possible to the sensor, because when you are going to start automatically checking for the sensor, then the Z movement is going to be really slow. And if the tool is very high, it's going to take a long time. So I'm going to move it somewhere here. And now I'm going to use this custom button, so the only button that is in Finnish here, so which probably translates to leveling, or like find Z0 or something. What does it mean, terän mittaus?
What?
Terän
Measurement, or like
terän mittaus.
measuring of the tool.
Tool measurement. Okay.
Yeah.
So yeah, so it's basically going to measure and set the Z0. And for that, yeah, also I'm going to use these, and hit the vacuum pump button. Make sure it's there, and then hit the terän mittaus button. Yeah. Now it's done. I can move the tool a bit aside and reposition the material. And now I need to set the 0 to the left closest corner. So the X and Y 0, I need to set that. And in order to do that, I will use the keyboard. So going to try to move the tool closer to the material, because this is how you can see better where it is along the X and Y axes. And you, like, unless you're doing something really precise, then it's just enough to kind of approximately set it. But what you should watch for is the 0. So you should imagine that in the middle of the tool there's a line. So in the center of the tool. So and you should align the X and Y according to that line. It's kind of laser, so you should imagine that there's a laser beam. Yeah, now I think I positioned it well. And once you've done that, then you hit 0x, 0y, and as you see these values become 0 in a similar way as on the SRM machine. Yeah, and the next thing is pull this up. And I'm going to install or attach the chip extractor or the dust shoe. It goes like this. So this is going to activate automatically when I run the job, and it's going to pull the chips through this pipe somewhere else. So now we are ready to start. I'm just going to activate the vacuum again. Close the door. So you see it's nicely sound isolating, and it's also safe. So there are two things. So next to the door, so the thing that you cannot see here really, so there's this panel, so where there's a green light. So like, so this one. So these two buttons, so when the green light is on, that means that the spindle is off and it's safe. When the red light is on, then the spindle is spinning and you should be careful. And then the green button below the green light, it's going to start running your job when it's loaded, and the red button is there to stop it. And basically the red button is also tied to the door. So on the door there's a sensor, so whenever you open the door during the milling process, the software receives a signal that spindle should stop. So be careful with that. So do not, if you see that something is going wrong and you don't want to stop the job, then don't open the door, because when you open the door the job is going to be stopped. And it's more like a safety stop, so which means that it stops everything immediately, and that means that it's going to lose some steps, so you will need to reset your Z and X and Y zeros. So yeah, well, in general, be careful. So make sure that your feed rates are right. That's the most important thing. So yeah, now I'm closing the door, and I'm going to transition to the desktop. And here, when we click load G-code, so we get the opportunity to load the G-code. So I'm going to go to the PC, and where did I have my flash drive? So yes, here it is. I'm going to insert. So there's a next to the monitor, and in the monitor there's a USB port, so you can load your flash drive from outside the computer, from outside the CNC room. And here I have the chair, and let's start with legs, yeah, because it's the material that we chose for the legs. And I hit open. Another cool thing is that here you will get a preview of the toolpaths. And on the left side, yeah, as I told, there's going to be the G-code. And now I'm going to press the physical green button that I showed a moment ago in order to start the job. Let me switch over to this one. it's gonna probably fail miserably. So yeah, as for downcut, you see that the top surface has a nice finish. With an upcut, you would see it's kind of destroyed. But here, like at the end of the process, you will probably not even need a sandpaper in order to clean it. Here's jumping over the tabs. Done. And yeah, just make sure that the red button is not on, so the red light is not on. And then you can ease the page up. Something happened. Ah, I cannot control because I'm not here. Yeah, you can move it aside. And the best is to use a vacuum cleaner to remove the dust. For now, I'm just going to move it aside and install the other material for the other part. And again, here I'm gonna close the previous G code, load the new one, and pick the chair top. Looks good, and press the green button.
Could we use the stock which is bigger than the vacuum platform?
Sorry?
Could we use the stock which is bigger than the vacuum platform?
Not recommended. I mean, if it's hanging over and you manage to find a way how to hold it down properly, then yes. But it's not going to move outside of the windows. Okay, nice. So we are done. So yeah, and from here you do the cleanup with a vacuum cleaner, and I recommend to use a chisel and a hammer to remove the tabs. Like so. And so yeah, this is going to be the end of this video demonstration. But then this is what should be, what is it? So that's an object that is supposed to come out of this. Yeah, so I'm just going to remind, so in this bag here you can find the new tools, so these are fresh and sharp, so yeah, but there's also a box of a bit older tools, so this is not bad neither. Then, yeah, once you're done, so of course you should clean up and everything, but then once you also clean up, then you move the machine a bit closer to where you can access it. Like so. Then you remove the dust shoe. And there's one trick that I want to show you actually that is really nice that I'm going to record. It's how to not hurt yourself when you are removing the tool. So you should arrange these two keys in a way that they are close together, so close that you can wrap them with one of your hands, like so. And then you can carefully push them together in order to open the connection, so that kind of loosen the thread. Because if you would use both hands, then you would arrive to a situation where probably there's a lot of force and there's a possibility of your hands to crash together, and this is how you can hurt yourself. So this is why it's better to arrange these together and just do it in small steps. And then, yeah, open this up, remove the tool carefully, and also put it back in its box, just right away. And not just in its box, but also in the storage over there, so that the next person can find it easily. And yeah. And then you can switch off the machine, and you start by closing the software. So yes, we want to end the session. Not this one. No, we don't want to save any fixtures. But then here, So it is important that you press this red button. It's the first step after closing the software. And then you should wait till these numbers here, they go up and down again, and then there's a click, and you'll see that there are letters L and U blinking. And then you look down, and there's this rotary knob, and you have to switch it to the off position. And that's that. Make sure that the room is clean. Now we're going to finalize the chair build in secrecy.